We're going to be looking at some more problems today where you're going to be solving some rational equations. So recall that a rational equation is any equation that contains one or more rational expressions. An example would be like this expression where this term right here, r squared minus 5 over r squared minus 1, that is a rational equation because you have expression on top and bottom, and maybe let's say it's equal to this. This term would also be a rational expression because it has both variables on top and bottom. And it's an equation because you see there's an equal sign there. Another term that we're going to be talking about is a extraneous solution. That's a solution that's created by multiplying by the least common denominator, but is not an actual solution to the original problem. Okay, so it's like when you solve it and you come out and you get an answer, it's just that when you plug it back in, the answer doesn't actually work because you get things like division by 0 or something else happening. So we're going to be trying some of these today. On number 1 here, we're going to be trying to solve and figure out what can r equal here to make both these two sides equal. So this is a little different than the ones you were doing before because you can see there's going to be some factoring involved. So let's go through first and factor everything possible. There's nothing to factor on this first one. On the second one, r squared minus 5 might factor, but 5 is not a perfect square, so it doesn't look like that factors. The bottom, however, does. 1 is a perfect square, so that factors to r plus 1 times r minus 1 equals. The numerator here, does anything multiply to 2 and add to 1? No, I don't think so, so that one doesn't factor. On the bottom, nothing factors either. Okay, so that is the factored form of this. Now we got to go through and get a least common denominator. It looks like r plus 1 is definitely involved, but that middle term has a r minus 1 as well. So we're going to need to multiply everything in order to get an r plus 1 and an r minus 1 in the denominator. So this first one doesn't have either right now. That needs both. So we're going to have to multiply by both r plus 1 and r minus 1 for that one. So we're going to multiply here by r plus 1 and r minus 1 to that one. And whatever you multiply on top, you're going to have to also multiply on bottom here. All right, the next one is r squared minus 5. Now this already has our common denominator, so we don't need to do any multiplying on that one. Equals this over r plus 1. Now this one doesn't have the r minus 1, so we got to multiply by r minus 1 over r minus 1. And what this is going to look like now is we got r times r plus 1 times r minus 1 in the numerator. In the denominator, we got r plus 1 times r minus 1. Plus, we didn't do anything here. Equals, and then on this one, we're going to have r squared plus r plus 2 times r minus 1 all over r plus 1, r minus 1. Okay, now just like we were doing in the previous lesson with this, once we get a common denominator, if we were to make these equal then and multiply by r plus 1 and r minus 1 to everything, the denominators cancel out. So our job now is to solve what's left of this problem, which is the numerators. So we got to go through and figure out, okay, what's this going to equal? Well, it looks like there's some multiplying we're going to have to do here. For example, right here we're going to have to distribute, so we get r squared plus r, but we still have another one we're going to have to multiply here, r minus 1, plus, there's no multiplying to do here, equals, there is some multiplying we're going to have to do on this one because we have 3 terms times another one term or two terms over there. So let's do the rest of the multiplying here. So this one we're going to have to multiply first, outside, inside, last. Here we're going to have to multiply this to both, the second one to both, and this third one to both. So there's a lot of multiplying to do on that last one. So if we multiply all this out, we're going to get r to the third power when we multiply r squared and r minus r squared. We multiply the inside ones, that's going to be plus r squared minus r, plus these two terms that were from the second thing. All right, the last one, r squared times r is going to be r cubed. R squared times negative 1 is minus r squared. R times r is plus r squared. R times negative 1 is negative r. 2 times r is 2r. And 2 times negative 1 is negative 2. All right, now we got to combine any like terms or cancel out anything we see. Well, there's an r squared minus r squared plus r squared. That would equal 0. And I think we got the same thing happening on the other side. There's some like terms we can combine here. So we'll combine those together. One other thing I noticed really easy here that we could cancel out as well is we have an r cubed on both sides. So if we minus an r cubed from both sides here, that would also cancel out. So what we have remaining then is r squared minus r minus 5 left on that side equals, on this side, if we combine those two terms, that's r minus 2. All right, so we got to figure out how can we finish solving what's left here. Well, I don't think we're going to be able to solve this with regular algebra because this r squared term's not going to cancel and our two r's won't cancel. So we want to get this equal to 0. This is a quadratic. So next step we're going to do, minus an r to the other side, add 2 to the other side. We want this equal to 0 in order to solve it. So we got r squared minus 2r minus 3 equals 0. I think we can factor this one now. What multiplies to negative 3 and adds to negative 2 would be r minus 3 and r plus 1. Now to solve this, put them both equal to 0 and see what you get. So it looks like we get r equals 3 is one solution and r equals negative 1 is another solution. Now we want to check, do these work out? Okay, are these both solutions or not? Because we got two answers, but remember that extraneous solution. So let's check 3. If we were to put 3 in for r, specifically the denominators, are we going to be okay here? Yeah, this would come out to be a denominator of 4, and this would be 3 squared is 9 minus 1. This would be a denominator of 8. 3 looks like it checks out. Let's check our other answer here of negative 1. Does negative 1 work out? Well, if we put negative 1 in, uh-oh, right away here, what's negative 1 plus 1? 0. Can we have division by 0? So this one, even though we got an answer of negative 1, that is not a solution. That's an extraneous solution. We do not want to use that one for one of our answers. So the only answer on this one is 3. 3 is a solution because that one works when you plug it back in, not negative 1. Okay, let's try another one of those. On the second problem, we want to do the same thing again. Start by looking at factoring. Nothing factors here. Nothing factors here. The last one, we do have some factoring. It's a difference of squares in the denominator of that. Okay, so now we got to get a common denominator. Looks like x plus 1 times x minus 1 is the common denominator. So go through here and multiply to get a common denominator. This one needs x minus 1 over x minus 1. The next one needs an x plus 1. And we got equals. Our final one here already has this common denominator. No multiplying is needed. So our problem is going to look like 2 times x minus 1 in the numerator, x plus 1 times x minus 1 in the denominator. Here we got our common denominator 2, and our last one still hasn't changed. All right, so now that we got a common denominator, if we were to multiply through by x plus 1 and x minus 1, all our denominators are gone. So now we just need to solve the numerators. All right, so if we solve this out, looks like there's some distributing to be done here. Distribute here, distribute here. Now, one thing to be really noticeable about, make sure we're distributing -1 on that second one, not just 1. So you got 2x minus 2 minus 1x. -1 times +1 is -1. If we combine like terms here, we got x minus 3 equals -2. Adding 3 to both sides look like our answer is 1. Now we got to check, does 1 work? Well, if we put 1 in here, we're fine. 1 plus 1, that's going to be denominator 2. Uh-oh. 1 minus 1, denominator of 0. Looks like 1 is an extraneous solution. That's an extraneous solution. So on the last one, we still had another option to go with as an answer, but here our only answer was extraneous. So if that happens and your only answer is an extraneous solution, that means there is no solution to this problem. There is no number we can put in for x to make these two sides equal. So this one has no answer. All right, let's look at another problem here. Number 3. Again, do the factoring first. Now this is a different type of factoring on this one. This looks like greatest common factor. So let's go through and do the greatest common factor of 3. Take that out. The second one looks like it has a greatest common factor of 4. And this last one has a greatest common factor of 2. Okay, now that we have all this factored, we got to come up with what's the least common denominator. So least common denominator here, we got to find what's the least common multiple of 3, 4, and 2. Well, I think all those go into 12. So 12 is going to be the number part of that. And then there's an n plus 1 involved, but then that middle one has an n minus 1. So that's also going to need to be a part of our least common denominator. So we're going to have to figure out what to multiply each of these to get to that value. So this first one here, to get to 12, we're going to need to multiply by 4. And then it needs an n minus 1. All right, the second one here has 4, so to get to 12, we're going to have to multiply by 3. And then this one has n minus 1, but doesn't have an n plus 1. So that's what we multiply there. Our third one has a 2. So in order to get to 12, we're going to need to multiply by 6. And then this one's missing an n minus 1. So now if we do all this multiplying, we should get a common denominator, or least common denominator here for all of them. So on top here in the numerator, 7n times 4, that's going to be 28n times n minus 1. And we should have our common denominator here. On the second one, if we multiply here, 5 times 3, that's 15 times n plus 1. All over 12 times n plus 1, n minus 1 equals. In the numerator here, we got 18n times n minus 1. All over, again, our common denominator. So now that we have all these denominators the same, if we were to multiply, they would all cancel out. So now it just comes down to, can we solve out this numerator? So we're going to need to go through and figure out, what does this give us? And there's going to be some multiplying involved. Looks like some distributing for sure here. So we got to go through and distribute each thing. Again, notice this one, make sure we're distributing a -15 or you're going to get the incorrect answer here. So 28n times n is 28n squared minus 28n when we distribute, minus 15n. -15 times 1 is going to be minus 15 equals 18n times n is n squared minus 18n. All right, this one again looks like a quadratic. We got n squared and n in the same problem. So let's move everything to the one side here. Looks like there's some like terms we can put together here too. And if we do that, we're going to get 28 n squared minus, sorry, that's going to be negative 28 minus 15 is negative 43n minus 15. Now if we move these two other ones over to the other side, minus 18n squared, and we can add 18n Now we'll get it equal to 0, and then we should be able to solve this. So we got 10n squared. This one should come out to be minus 25n minus 15. All right. To solve that, we want to probably do some quadratic formula or factoring. I see one thing right away that we could do to make this easier. It looks like all three of these numbers are divisible by 5. So let's divide through here by 5 to make this a little easier. So we don't have quite as big of numbers to deal with. So that'll be 2n squared minus 5n minus 3 equals 0 divided by 5 is still 0. I think this one might factor here. So since we have 2n squared, we're going to need a 2n and a 1n. Now we got to figure out what multiplies to negative 3, and we'll also end up adding to negative 5 when we multiply through here. Let's just try one out. Negative 3 would be something like with negative 3 and 1 here. So let's try, I don't know, let's try minus 1 and plus 3 and see how that works. If we were to multiply these out now, this would be 6n, and these middle ones would be minus 1n. Do these two add up to our negative 5? No, those add up to positive 5n. So I think we can get this one to work if we were to just switch the signs around. Okay, so let's change this to plus, and let's change this one to minus. Now if we were to multiply those, you'd get 1n for the middle ones, and the outside ones would be negative 6n. Those do combine to negative 5n. So that looks like how you would factor that one. You could also at this point in the problem do quadratic formula, and it should work out to be these same answers. But now we want to put these both equal to 0 and see what we get here. Here we just got to add 3, and one answer is 3. On this other one we got to first minus 1 and then divide by 2, and it looks like we get negative 1/2. So we got negative 1/2 and 3 as answers. Now we got to check. Do these work, or are some of them extraneous solutions? If we were to put 3 in, I think we're going to be fine. 3 would make this 12, 3 would make this 8, and 3 would make this one also 8. And I think there's no division by 0, so 3 looks like it's a legit one. If we put negative 1/2 in, the first one won't equal 0. This one's not going to equal 0. None of these three would end up being division by 0. So it looks like this one actually has 2 solutions. Both solutions check out, so this one has 2 possible answers to it. Negative 1/2 and 3. And that could happen. All right. On the next one, again, we want to go through and get a common denominator and see if we can solve this one out. Why don't you pause the video, try this one on your own, and see how you do on this one. All right, if you factored this out, you should have saw that the common denominator is going to be p plus 1 times p minus 1. This first one here and this last one then do need to get multiplied by some stuff to get a common denominator. If you multiply through and cancel out the denominators, you're left with what we have here. So now you got to go through and keep solving here, do some multiplying. This one you're going to have to multiply 3 things by 2, so you should end up with 6 things when you're done. P squared times p is p cubed, minus p squared times negative 1 is going to be minus p squared. If you multiply the next two, you're going to get another minus p squared. P times negative p times negative 1 is plus p. 1 times p is another p, and 1 times negative 1 is negative 1. We got these. Now here we got 3 things to multiply. You got to start by just picking 2 of them. Let's multiply the first 2. So that'd be p squared plus p if we distribute that p. But now we're going to have to multiply times this other one. So if we were to do that, you're going to get p to third power minus p squared plus p squared minus p. So now what we have to do is go through, combine like terms, see if anything cancels or anything like that, and solve this problem out. So just looking at this one, I see there's a p cubed on both sides, so that would cancel out. These p minus p squared and plus p squared, that would cancel out. I don't think anything else cancels, so now we want to combine like terms here. You got negative 2p squared plus 2p minus 1 equals p squared minus p minus 7 on this side. Since nothing else cancels out, we want to get everything on the same side, get it equal to 0. I'm going to add 2p squared here minus 2p and add 1 to both sides here. And we'll see what we get. So this side's all going to cancel out and be equal to 0. Here we got 3p squared minus 3p minus 6. To solve that, I think we can make this easier by dividing everything by 3. We got p squared minus p minus 2. That is definitely factorable. I think minus 2 plus 1 is going to work. Those multiply to negative 2, add to negative 1. Putting them both equal to 0 now and solving. We get 2 and negative 1. 2 will check out if you go put it back in, but this other one of negative 1, that's an extraneous solution. So this one just has the one solution of 2. Negative 1 does not work. You'll get division by 0 if you plug that back in. Okay, a couple other problems that you might need to use some common denominator stuff to do. On number 5, it says Brianne and Owen paint houses together. If Brianne can paint a particular house in 6 days, Owen can paint the same house in 5 days. How long would it take the two of them if they worked together? Well, in this problem, we can't just add them up. It won't take them 11 days if they work together. That's even longer than if they work separately. So we don't want to add them. Also, I don't think subtracting works here. If you subtract that, that's 1 day. That seems way too fast for how long it takes each of them separately. What you have to do in a problem like this is compare what they can do in not 5 days or 6 days, but how much of a house can they paint in 1 day? So if we start with Brianne, okay, we'll call Brianne what Brianne can do in 1 day, or to paint a house it takes her X amount of time. In 1 day then, if we divide this by 6, that's how much she can get done in 1 day. She can basically get done 1/6 of a house in 1 day. Owen, he can do it in 5 days. So if we divide his by 5, that's how much he can do in 1 day. They're going to work together, so we're going to add these up to equal how long it would take the two of them if they work together. So together they're painting one house, so we would set this equal to 1. If it said, how long would it take the two of them if they work together to paint, let's say, 3 houses, if that was the question, then instead of 1 here, we would put a 3. So it just depends on what they are asking you to do. So this one, we would want to set it equal to 1 because together they're painting one house. So to solve this out, we got to get, looks like a common denominator here. What's the least common denominator of 6 and 5? It would be 30. So let's do some multiplying here. We got x over 6. This one we're going to want to multiply by 5 over 5 plus this next one we're going to want to multiply by 6 over 6. And this last one here of 1, to get a common denominator, we're going to have to multiply by 30 over 30. All right, so now we got 5x over 30 plus 6x over 30 equals 30 over 30. Our common denominators now should cancel out, so if we just solve the top, we'll get the answer. We've got some like terms here. That's 11x equals 30. So it looks like x would be 30 over 11 days. Whatever that comes out to be should be the answer. Just so we can kind of get a kind of a feel for what that is, let's divide that in here. 30 divided by 11. Looks like about it's going to take them about 2.73 days to do that. So if they work together, that's how many days it will take them. All right, one other problem here was that you might get some rational expressions. It says ratio. Remember, ratio, those are things where you can list it with a colon or as a fraction, something like that. We're probably going to want to use this fractional way since we're dealing with a word problem here. So it says the ratio of 16 more than a number. Okay, 16 more than a number. That would be like some number adding 16 to it. 2. 2 tells us now we're switching the part of the ratio that we're looking at. So over 12 less than that number. Okay, so this is referencing that same number we were talking about here. So x, and if it's 12 less than that, that would be minus 12. Is, in math, is always a key word for equals. And now we got another ratio over here. 1, 2, 3. 1, 2 means we're switching sides of the ratio. 3. So they want us to figure out what would make this equal to each other. Same thing we did on the last one, get a common denominator here. What could we multiply by? Well, this side needs an x minus 12. This side needs 3. So if we multiply to get common denominator, we got 3 times x plus 16 over 3 times x minus 12. On the other side, we got 1 times x minus 12 over 3 times x minus 12. Okay, now that we have the same denominators, those are gone. Now just solve the top, and we got the answer here. Looks like we're going to have to do some distributing. On this side, that'd just be x minus 12. On the other side, 3x plus 48. If we keep solving here, we could minus an x, minus 48. So that'd be negative 60, divide. Looks like negative 30 is the number that makes this work. And if we look at negative 30 plugging back in, that does not make the denominator 0. So that's a legit answer. It checks out. So negative 30 would be the answer. All right, try some of these on your own then on